Hello everyone. Today we are presenting our CI/CD pipeline design in our startup, which we made almost 2 years ago, called TopUp. TopUp is a platform that solves problem of much organization and also for venue owners and tournament helps with tournament organizations. And here we have 3 repositories: web application for venue owners, and mobile for users, and backend for API. And Stack, Flutter for mobile, Next.js, React for front-end part, and Golang for backend part. And also NoSQL and PostgreSQL. And second environment, we have 2 environments, production and development. Next, why CI/CD? The manual deployment problem. Manual SSH deploys, so SSH deploys. Teams should manually connect to server for pulling code and restart containers for every update. And with CI/CD, we can do it automatically. And it can cause manual SSH deploy can cause errors and very slow. And no environment isolation. We have now, as I said, the development and production environment. So in manual deployment, we don't have environment isolation, and our code is mixed. And inconsistent builds. And we can hear from our teammates, works on my machine, so it's very popular. And so because local environment have difference from production, and zero rollback strategy, deploying poorly meant many hours for manual recovering data, and there was no source of versions to artifacts to automate that process. Next, we have our pipeline architecture overview. And first of all, a developer pushes his code and GitLab refers to GitLab repository, and CI pipelines triggered on push, and Docker image built and deployed to our server. And our Docker image only deployed to production and development. So production uses in Git main master branch builds image and sends deploys to port 9091, and development dev branch we're using, and for local feature there is no pipeline. And technology stack, Nginx we are using for subdomains to routing 8+ subdomains to current containers and handle SSL termination. And Docker we are using for building and packaging, and GitLab for artifact store, and SSH for secure development. And next, Docker image creation. First of all, runner logs into GitLab container repository, and the Docker in Docker we are using service, so it will be enabled, and then image built from Docker file using commit sh8 tag, and there we go to push. We are pushing to GitLab repository, and only runs as you see there, master and dev. And in the end, we can show a demo of our code, CI/CD pipeline, and Docker image building. Next stage.
So let's talk about the implementation, deploying stage as such to production servers. Once the image is built and pushed, the deploy stage kicks in, but only after the build stage completes successfully. It means it uses a lightweight Alpine image with the SSH client already installed. The runner connects to the VPS over SSH using a private key stored in CI/CD variables. It pulls the freshly built image from the registry, stops, and removes the old container, and starts a new one with the appropriate environment variables that already was injected. The port depends on the branch. Dev deploys port 8081, production port 9091. Nginx then handles routing. It means each subdomain to the right port. Critically, all secrets are stored in GitLab CI/CD variables with the prefix. They are never written to disk or committed to the repository. So next slide. Multi-stage Docker file. The multi-stage Docker file deserves its own slide because it's one of the most impactful decisions we made. Stage 1 is the builder. We use the full Golang 1.24 Alpine image, download all dependencies and compile the binary. Everything needed to build the application lives in this stage. Stage 2 is the runtime image. We start fresh from plain Alpine, Linux around 5 megabytes, and copy only the compiled binary from stage 1. We also add time zone data so the server runs on Asia Almaty time. The result is a production of image roughly 10 to 15 megabytes compared to over 300 megabytes if we ship it the full builder. Smaller images mean faster pulls, faster deploys, and also a smaller attack surface in the production. So the next slide, uh, it's about infrastructure and Nginx routing. The entire system runs on a single VPS rented from hoster KZ. We rent from hoster KZ, so like 2 CPU cores, 2 GB of RAM, 50 GB of storage, and it was OS on this was Ubuntu. It's accessed exclusively over SaaS with a non-root user. The provider handles automated backups every 4 hours, and we have CPU and RAM monitoring built in. So Nginx sitting in front of containers and routes requested by subdomain. So the next slide, uh, it's about challenges and solutions. Let me walk through 4 real problems we've hit. First, Docker in Docker was throwing security warnings about the storage driver. We fixed it by explicitly setting storage driver equal to overlay 2 and scoping privilege mode to the CI runner only, not the production containers. Second, early in the project, someone accidentally committed the end file with the real credentials. We immediately rotated the secrets and moved everything to GitLab CI/CD variables. No secret has touched the repository since. And third, the running dev and production on the same server created port conflicts. So we solved it by assigning fixed, distinct ports per environment and enforcing the separation at both the container engines. And last, it's our yearly Docker images were over 300 megabytes, which made deploy slow. Multi-stage builds brought that down to around 15 megabytes. So the next slide about the lessons that we learned, and here's what we take from this project. We added CI/CD, we learned setup CI/CD from day one. We add CI/CD mid project, add automated testing to the pipeline, monitor deployment, post-release multi-stage builds are non-negotiable, use container registration, and keep secret management strict. And this next slide, it's about demonstration, and Samara to talk about it.
Here we have demo screenshots of 3 different stages. So first one is our Docker image building and CI/CD. Second one, CI/CD pipeline. And here I can say GitLab spins up a Docker runner, and then the runner first logs into the GitLab container registry using credentials stored as CI/CD variables, and then it runs Docker build using our Docker file, tagging the image with the current commit, and finally it pushes the image to the repository. The multi-stage Docker file is is key. So the first stage compiles the Go binary using the full Go compiler, and the second stage copies only the binary into minimal Alpine image. And here you can see our actual code. And so that's all. Thanks for your attention.